This is a uniform motion problem again, and we've already got the table set up for us. We will remember that rate times time equals my distance. Chrissa traveled to her grandmother's house for a weekend visit. She averaged 40 miles per hour there on Friday, going to Grandma's house. Returning on Sunday, traffic was lighter, so she was able to average 48 miles per hour, and her driving time was 1 hour less. What is the distance from Chris's home to that of her grandmother? Her rate going to Grandma was 40 miles per hour. Coming home was 48 miles an hour. We don't know how much time it took her driving on Friday. We'll just say that's X time. And on coming back on Sunday, it was 1 hour less. So that will be X minus 1. And then I multiply those together to get my distance. So 40x. So 48 times x minus 1. Now I use these distances to set up my equation. They don't tell us anything else about, oh, but wait a minute, she went to Grandma's house, she came back from Grandma's house. Wouldn't that be the same distance? So my 40x equals the 48 times x minus 1. So 40x equals 48x minus 48. If I subtract 48x from both sides, I'll get negative 8x equals negative 48, and x equals 6. Now, x equals 6, but what's x? X is the time. And the question asks, what is the distance? So to answer distance, we better have miles. So if her time is 6 hours, traveling at 40 miles an hour, 40 times 6, that will equal 240 miles. And that would be the distance between Chris's house and her grandmother's. Now we have another type, a mixture problem. Charlotte Bess is a chemist. She needs a 20% solution of alcohol, but she has on hand a 15% solution as well as a 30% solution. So how many liters of the 15% solution should she add to 3 liters of the 30% solution to get her 20% solution? For these problems, I set up percent times the amount equals the pure. How much is pure alcohol in this case? She starts with a 15% solution. How many liters of that? We don't know. So that comes out to be 0.15x. Remember that when you're working with percent, you have to change it to decimal form. And she has a 30% solution. She has 3 liters of that, so we'll have 0.30 times 3. Now, this last in the bottom row is the mix. She ends up with a 20% solution. Well, how much of that does she have? She has the 3 liters of 30% she started with, plus whatever she added to the 15%. So she has 3 plus x. And how much is pure? Will be 20 times 3 plus x. Now, here's where it comes up time to set the equation. The two solutions you're going to add together give us a certain amount of pure alcohol, and that same amount of pure alcohol would be in my final. So my equation becomes these two added together equals the mix, the amount of pure. So 15 hundredths x plus 30 hundredths times 3 plus equals my 20 hundredths times 3 plus x. Now the first thing I'm going to do is actually multiply the entire equation times 100. We multiply each term in the equation times 100. So the first term is 15 hundredths x times 100 is 15x. The next term is 3 hundredths times 3. So to multiply it only once times 3, it becomes 30. Or times 100, it becomes 30 times 3. And the same here. This is one term. So multiply the first part by 100. that will be 20, and then we don't do it to the second part, only to the first part, only to the term once. So we end up with 15x plus 90 equals 60 plus 20x. If I subtract 60 from both sides, that would give me 30. And I subtract 15x from each side, that will give me 5x. And I found out that x equals 6. So I need 6 liters of the 15% solution. And that would be my answer.